We are live.
Well, that was a little different. So sorry for the technical difficulties earlier. So what happened was we were doing multiple streams, and we think that there was a technical difficulty caused by a stream that was ending as ours was starting. So it threw our hardware for a loop. So we're actually switching over to this other platform we've been using, StreamYard. So anyway, that's a long way of saying very sorry for everybody's having to wait, but we are back now. We are on Twitch and YouTube. We're using StreamYard today, as I just said a minute ago. So any small hiccups, we'll probably be able to solve very quickly. It's pretty easy to work with. Um, and yeah, again, I apologize for everybody's wait. Wendy will hopefully be able to join us. We'll see. I think she's troubleshooting those issues that are on her hardware side now. I want to get right into things because Mark has been with us since 6:30 this morning at his time. He's in New Zealand, but we have the CEO of Nextspace with us. Super fascinating story. Oh my gosh, when you hear about some of the companies these folks have worked with over the years and how they kind of recognized the importance of a really strong file format to stand the test of time, you're in for a real treat. So I will say really quick, because I do want to get started. GTC is about 6 weeks away. I was going to show a few slides. I'm going to skip that. But so the key message here is go to nvidia.com/GTC. It's really like almost all the content is 100% free, and it's all virtual. So a lot of great sessions concerning metaverse, digital twins, of course, Omniverse. We have our user group there. We'll talk about that more in our next week's stream. So we can dive in right now with Michael and Mark. So Mark, before we introduce you and your great story, we have a special guest here who has worked with you closely over the, well, I don't even know how long, if it's been months or longer, but Michael Clive from the NVIDIA team, thank you so much for joining us. We really appreciate it.
Thank you so much. I'm glad to be here.
So before I'll let you introduce Mark in a second. But why don't you tell us a little bit what your role is on the Omniverse teams? Kind of people could put the relationship in perspective.
So I run a developer technologies group here at NVIDIA for the Omniverse platform. And developer technologies is a very specific meaning within NVIDIA. And, you know, in other worlds, for more engineering, kind of, more mechanical or, electrical engineering, is kind of applications engineering is the quickest, like, little comparison. But it's a bit more than that. And, it's we exist to ensure that developers can succeed with NVIDIA platform software and hardware. So, developer like, Nextspace, working with NVIDIA, working with DevTech, can produce a product that can delight customers, take full advantage of NVIDIA hardware and software, and, put Nextspace in a competitive leading edge, or, whatever company it be, right? And DevTech of Omniverse is very broad. We have, Omniverse is very broad, thus the Omni. And, we are here to provide, advice, guidance, code samples, white papers, best practices to, qualify software developers that are trying to, make their business with Omniverse.
Very cool. And so all over the world, you guys have kind of people that are able to help. So that's pretty fascinating. As I just said, our special guest here is dialing in from New Zealand. And it is Thursday there, and it's Wednesday here, so even more impressive already. All right, so why don't you tell us a bit about Mark and Nextspace and how you guys started working together, and then you could give him proper introductions.
So Mark is perfectly capable of introducing himself, but I will do my best, Mark. Mark has this company right now, Nextspace. But Mark and his team have been around for a long time in the computer graphics, visual effects, and industrial industrial graphics world. Some people who are in this stream who were going to SIGGRAPH back in the early 2000s might remember something called Deep Paint 3D. Which was a really cool way to paint textures in 3D space. That was something that came out of Right Hemisphere, which is I don't know, Mark, is that your first company, second company? I don't know. You've been an entrepreneur.
It's all kind of been one long company with different names, but yeah, it was kind of number two after CADs and computer-aided design, which morphed into Right Hemisphere, which is kind of morphed into Nextspace and branched off to SAP. We'll talk a bit more about that.
Mark, don't interrupt me when I'm introducing you.
Sorry.
No, it's okay. It's okay. I'm just joking. Yeah. So what him and his team have been working in computer graphics, for a very long time. Some of the projects they worked on was things like the 787, for Boeing, to make sure that Boeing could do fully digital drawings that could be, handed off from engineering to actual manufacturing facilities without having to have stacks and stacks of printed PDFs. You could actually have your mechanical drawings, done in 3D and 3D PDF. You could look at this 3D PDF and look and see what the tolerances were on this thing, which is really important when you're starting to talk about complicated aerospace structures that kind of exceed the capacity of a two-dimensional drawing from capturing. So that was something that really impressed me when I found that he's involved with that. Most recently, his company's been working on, this digital twin thing with Nextspace and Bruce. And the synopsis from my perspective is this. There is a layer. There's a very deep web of layers below every built and constructed object that you interact with every day. Every road, every street lamp, every cup, every bowl, every glass has some Mark's word here is ontology behind it that describes its relationship to how it was made, where it came from, where it's going. And from my perspective, Bruce is this platform that allows the analysis, integration, and interrogation of this web of information that covers everything. Where did this part come from? What is it made out of? When did it get here? What is its relationship to this other part? And having deep and rich access to that layer has been a huge challenge in industry, and it's something that only in the past 10 years have we actually really started to kind of approach it programmatically with software, in a broad sense. Like individual companies have a little silo. So Mark, was that a good enough introduction? Do you want more? Do you want less?
No, that's great. Thanks, Michael. And hopefully I won't contradict anything.
No, feel free to contradict.
No, it's I think that's a great introduction. Thanks, Michael. Yeah, we've had certainly quite a long history across a range of different computer graphics, from engineering to the entertainment industry, architecture, manufacturing, engineering, GIS, and so forth. Just many years, and certainly it's very interesting. There's commonalities and there's differences, but we're certainly focused on the commonality of problem, across many of those different industries over time, and built with the evolution of the cloud technology and web rendering and some of the more modern developments in this space. Some things we only dreamed were possible back in the 90s, and we can now actually deliver on. So it's exciting times.
Well, I think that your background and like I said earlier in the stream, the fact that you recognized that the file format was going to be super important to the longevity and the usefulness of digital twins. And look at some of these clients that you've worked with. I think everybody will recognize some, or if not most, of these companies. A pretty impressive list. And what's the so is the common theme here that you really did help digital twins with these companies here?
Yeah. I think the term digital twin is a term you always want to be careful with. Even today, I think it's already started to carry some baggage, and information, and it might be useful. I'll talk a bit more about what our view of a digital twin, but generally, it's about representing the real world in a digital sense, and that means a way to actually represent the way things were, the way they are, but also when you run this digital twin structure through analytics and AI and simulation, you can create the way things might be. And so we really focused on this job of putting together a framework which firstly can represent things as they were and as they are, but also, after running these simulations as they, might be, and then be able to actually, feed effectively the simulation AI and the visualization and create a symbiotic, structure of relationships between the things we care about, the attributes of those things we care about, the relationship between one thing and another. Is this a parent-child? Is it connected to this? Is, this piece of media attached? And then ultimately, what does it look like? Its visualization. So we've been building, we're digital twins here. We're working with, companies like SpaceX and Boeing. We built some of the first billion polygon renderers and so forth. But more importantly, I'll go through, there's some of our partners. I'll perhaps dive in and do this. But the first company, we had was actually working with these was acquired by SAP, who we work with very closely. I mean, a huge amount of the world's data is stored in there. But I'll just go through some of the things we've done in the past. Was we built billion polygon renderers to represent the whole 787 back in 2000. In fact, was it slightly earlier than that? We built 3D PDF technology because we had to bring together not just the graphics, but all of your dimensions, tolerances, annotations, what they call FTNA, feature tolerance annotation, or PMI, product manufacturing information, and to be able to reconstruct that into all of the views, so to turn what was a pile of 100 drawings into a single PDF was the challenge. And a drawing is made up of multiple different views, sections. We turn on dimensions, we turn on tolerances and information, we restructure the bill of materials from drawing to drawing. What if we could represent all of that in one PDF document where you had a 3D model in the background and all the views were able to be controlled interactively? And so in this respect, we created a system that all ran through servers that would take, the 787 models down to individual sub-assemblies and create one PDF document to represent 50 or 100 typical 2D drawings and then communicate that. We built some of the first, virtual augmented reality solutions for the Joint Strike Fighter project with Pratt & Whitney, unifying data from Unigraphics and CATIA and ProEngineer into a augmented reality representation using, because we built a file structure that could represent engineering data down to all of this detail level, but also as Michael, it was good for 3D painting as well. We could have animated fairies, dancing on the wingtip of a 787, but it was, bringing that together actually was much more useful for augmented reality than dancing fairies. But we could bring that skin and bone structure together with engineering data in a way that, was not possible. We built 3D PDF. That was our technology licensed to Adobe back in the 2000s. We did some of the first 3D publications with Harvard and Nature magazine. But I just wanted to talk a bit about what we're doing with digital twins. We have a digital twin journey we talk about, which is bringing data together and enriching it and finding patterns. But I thought I might just jump in and show something on screen and then talk about perhaps how that's achieved, the background behind it. And I really encourage people to just ask questions. I sort of got demos and bits of PowerPointers, but we were going through with Edmar earlier and Wendy, and we very free form today in terms of questions, Q&A. But let me bring up a couple of things on screen. Firstly, I will bring up. So let's have a look. I'm looking here at a screen, and we'll talk more about what this is later. But this is we're looking at a cesium-based renderer for which is able to render, it does good enough graphics, and we can go through and interrogate an object piece by piece. And this is great. You go, well, this is all author, but here's all the information. So we'll change that piece of data there, which is the NVIDIA. I'm running out of imagination today. But if anyone wants me to change that, but I've just made a change to some data related to a model. So this individual blade, everything has its own data and so forth up here. And I can choose to look at that same model. So here we have the same model loaded into Omniverse. And today, if we have time, we're a bit short on time, but we'll see if we can we'll go through the whole workflow. But here's the same model, of course, much more beautifully rendered in the Omniverse. But what's really important is that it's all the same data. So if I click on this blade, I can bring up an information panel, which actually shows the same data that we see here. And you can see here the NVIDIA demo blade. We just changed that.
Presto. That's awesome.
And not only that, but if we go and we follow this link here, it takes us to the same information in a database. And so if I refresh that in the database, we'll see it says the NVIDIA demo blade. And if I was to go out here and say, let's export this digital twin out to Unreal, I can click on that and I make the link, and presto, we see the same model in here in Unreal. And
That's
if I
awesome.
click on a blade in here, we will see the same information. And if I change the graphic, we were to go in here and we'll go one blade up, and this one doesn't have a picture on it, so we'll go and get a picture of some. We'll put a I think I even have pictures of turbine blades. There we go. We'll pop that turbine blade and we'll pop that. So that's on that blade now. So we see that one, and the information on that blade is our new our new blade.
All right, Michael left off in the introduction that you're a wizard.
Michael, why didn't you tell us?
Oh yeah, no. This is all this stuff. The thing to note here is that this part looks easy because Mark and his team made it easy.
Yeah.
Yeah.
And one has to use, if one has not worked in manufacturing, one might have to use their imagination to understand that, like, the changing of the additional of that little, like, NVIDIA blade, right? That's a demonstration. What we're really talking about here is you click on that turbine blade, and there's every X-ray inspection of that turbine blade that has happened in the past 10 years, right?
Yeah.
Click on that blade, and you know exactly what foundry it was made in, exactly what heat, what lot could code, like what factory, if it was deburred appropriately, what the drawing is, part number, its replacement cycle, all of that stuff. And most importantly, you can be standing there in XR or an AR, right, in front of your, machine, and you can look at it and you can say, I wonder what the part number is on this gadget. And, you can't make it out because it's been smudged over oil. You look at it and you look at a digital twin, click on it, and there it is. Everything you need to know, like everyone, like person to go talk to buy the thing, right? So that what he just showed you is the simplest possible expression of this incredibly wealthy stream of information that this platform is giving you access to as an engineer or technician or whatever persona you are.
It's thank you, Mark. And it's one of the things that we found over many years. We like to joke that we've made more mistakes in the world of digital twins than anyone else, and there's a certain truth that, and one of the things is the word digital twin, as I say, carries some baggage, so I want to be cautious of that. But this is about, building the ontology or the complete understanding of things, which, is not just about their, what they look like, but quite a depth. And so, it's about bringing all of this data together, and figuring out the data schemas, the structures, and so forth. But the big value of this is that when you create a 3D presentation model, digital, whatever you want to call it, some kind of 3D user experience to find information about your world. The big challenge is not creating it for the first time. The big challenge is how do you keep that relevant next week, next month, next year, next decade, next century. And so it's building, an infrastructure that allows the dynamic changing of data, and even data schemas. There will be new standards. Someone will come up with Omniclass version 2. There'll be Uniclass version 5. There'll be, no, we want this data standard. And so being able to deal with data standard changes, links up, we've just put in a new document management system. Oh, we've changed our ERP system. We've now got a new CAD system we need to integrate. And you have to look at what's the constant here? What's the actual constant that we can actually rely on? And it goes back to a principle. We'll come back to that link, but back to this principle of ontology, which is what the Greeks came up with, that we have things that we care about. Those things have attributes that we need to care about. And these things have relationships to one another, parent, child, connected, upstream to downstream from, supplied by. It's generally a bidirectional sort of thing. And then lastly, we have visual proxies. What are these things? What are all the possible ways these things look like? And to highlight that, here's an example here of we can ingest data, and we'll talk more about, from plant and process information. Ultimately, we get a valve, which might be a 3D CAD model. But guess what? That valve, the same valve with the same tag number, all the information is represented in what's called a P&ID, process and instrumentation diagram, as a little symbol. It's represented in what's called an ISO, which is a kind of a semi 3D representation. Oh, and someone did a point cloud scan of this thing. Oh, and it appears in these diagrams, elsewhere in my network. Oh, I have these documents or performance things linked to it. And ultimately the valve, and you go, so what is the valve? And the truth is the valve is not the 3D, it's not any one of these visual proxies. It's actually a conceptual, unique thing in the universe to which we actually connect visual information, attribute information, external links. And so by taking this ontology approach, we can actually manage, the data. We can deliver what we showed earlier, which is, it doesn't matter whether I'm viewing that, that turbine blade in Epic, Unreal, or Omniverse, or Unity, or on a 2D diagram or on a map. It just doesn't matter. As long as we know, we can get back to that absolute unique ID. And so this is all about ontology. And so managing data over time is the job, we feel, and is what we learned of a relational and graph-based database system that manages all of the different file formats and structures and global unique IDs that exist within different file structures and systems. Mm-hmm. So to be a useful, single source of truth, people talk about. There's been a large move to data lakes, and they're great, but ultimately you've just moved a whole lot of unstructured data from one place to another, when what your AI and simulation tools are really looking for, and your visualization, is consistent and coherent data schemas that are joined together so that your raw data is ready to be analyzed by AI and machine learning and simulation and visualized and create a network. So, if we could bring all this data together, we can then, visualize it, but also analyze it. So, creating an environment where we represent the world as it, as it was, as it is, and as it might be. And so, when AI and simulation, it knows that a pump thing is going to have this data schema, these geometries, that if I'm analyzing a pipe network, it's going to have this connectivity information stored in this way, the geometry is going to be accessible in a 2D format in this way and that way. And so it's all prepared, and we run it, and the results of that come back into the same data model that we choose to visualize it. And you know, with so much in the Omniverse there, you know, in the worlds of simulation, this is a whole bunch, you know, this is where the Omniverse exists here and here.
Yeah.
And we can provide a framework. And one of the challenges, you know, to data management that people have is, you know, well, we've got so many standards, and so we have all these tools that we can literally draw the relationships and the mapping between, you know, our different representations of our pump, our valve, our engine, or whatever it is, from different financial systems and the manufacturing system. Everyone's got their own taxonomy view of what, you know, what's important about the things they care about. What if we could just join them with lines and put little functions in the middle of this? And again, that's what we do. This is the heart of data transformation, to unify to a common view so that we can navigate through an architectural environment, click on an object, see everything in an, you know, Omniverse environment, say, let's find everything that has this material by attribution and apply this material on the object within Omniverse, or let's link it to an IoT device. So it just creates a scalable kind of environment. So these are, you've seen these pictures. So maybe we'll go from here and just have a look at some very simple examples that while we have time. Just, are there any sort of big burning questions out there people have?
Yeah, definitely. Feel free to post your question in the chat, and we'll read them out loud or show them on the screen for Mark. Really like fascinating stuff, though. I can't believe you know, how involved some of this work really has to be, and the fact that you you know, you guys have been working on it for so long is really impressive.
Yeah.
So here's so we might have to use the previous, you know, I'll show you something I baked previously, but let's walk through the really fundamental process here. I'm going to bring in, you know, a CAD file, and you can see there's a whole bunch of different formats. Now, just while that's uploading, I'll go back and just show the process, and we'll try and do sort of two things at once. So if we have a look at the first part of this process, so today our workflow is that we bring in your model, IFC, add, you know, we add documentation schemas, and you manage in this database process. Then we export everything into the Nucleus server, and it becomes available within the Omniverse environment. We're also moving to a new model, which enables us to, you know, bidirectionally link, so we can start in the Omniverse environment. You read in your CAD models, and then we database and graph-base enable that, which then pushes it into the server and republishes it. So that you know, a process of bidirectional connection between the USD structures of Omniverse and this relational, you know, graph-based database concept, which is what we have here. So we're just running this file analysis, and so I may have to show things being baked. We've got a lot going on today.
I can ask a question here.
Yes, sure.
So one of the things that comes up with USD often is people notice that USD doesn't have any sort of GUID, global unique identifier system or anything like that, for good reason. But how has that been for you? Because IDs are important for you, right? How have you been able to work with that?
So we essentially GUID enable USD, but we do it. I mean, the issue of GUIDs within the USD is a slightly different issue to what we're talking about, and it's important we don't sort of confuse those two issues. Essentially, what we are doing is, let's just bring that this diagram back up, is that as we bring in an object, you know, and uniquely identify it within a foreign system, there will be some key, you know, let's take SAP, for example. There's a combination of what's called functional location and material ID, or within another system there'll be a unique identifier for that thing of interest. So there's always a way through APIs to uniquely identify things. Within an IFC or a BIM model, there are global unique IDs, at a assembly, sub-assembly managed instances. So what we're doing is we're embedding that process, embedding that ID into the data as we get it, and then when we make the actual USD or whatever graphic process. So this is the standard. So if I go into this, we're creating a new standard name, so I can run the import, or I can select an attribute to pre-sort this data. For example, it will carry all of that information. So I'll run that import. It'll run the process, and we will end up with a data model. I'll actually go into one that we brought in earlier and just open a new link while we're doing it. So it's created an entity type. If we look at this of this wing, so it's an item here, or if it's an IFC model, for example, it'll break it down into a beam. We can look at the data schema for a beam. We can add to that data schema. We can decide what's shown, what's not shown. So we're actually sort of taking control of the GUID, external. And when we create the USD, we're then embedding that GUID into the attribution of the USD. So anytime I then use that USD as a visual front end, I can then retrieve through our APIs that unique ID, and I can get back to, all the information that lives on this fully cloud-based database. So that's how I can synchronize. So my USD becomes a container for the geometry and the material and all the visual aspects of a thing. But ultimately the data, all of your links to live information about how many I've got in stock, or the latest engineering bulletin, or whatever. These are dynamic data systems that will live in the outside world. And our job is simply to be the map and the portal to that data, not even to be the repository of that data. We don't seek to be, we can store that data, but ultimately, the supply chain information about that thing is going to live and continue to live and be dynamically changing within an ERP system, or in an IoT system, or in a financial system or something. Our job is to make sure that USDs, if used as a visual proxy, a portal or a user interface. And this is the key issue for, everyone talks about the metaverse. Ultimately, we see the metaverse as about, 3D is a wonderful way to experience a digital copy of the world. It's a very complete view, but ultimately it's just a user interface. And the real challenge behind, both the consumer and the industrial metaverse is the ability to connect all the right pieces of information through this visual interface to the consumer of that data, whether they're professional consumers or what have you. So this is our job, is creating this network ontology. Sorry, I'm whittering on a bit. Please stop me.
I'm going to jump in and kind of answer the same question a little bit. So USD in its own right, of course, has made a decision to not have GUIDs as a part of USD. However, there is nothing that stops one from giving an object a GUID that is not, a critical piece of information for USD parsing. So it can just be a string or a text, or like you can attach anything you want to any primitive. Like, that's great, right? So the cool thing about that is if you have this object and you give it a GUID of AXT or whatever, then you can always link that to any backend database you want in any number of ways. Now, this doesn't stop you from, let's say, having this object also of the AXT GUID, and then that could cause a collision. But that's kind of on you to figure that out, right? But the critical thing here that was mentioned by Mark, and I do have to note, unfortunately, I do have to jump to another meeting. But is that it's kind of the single source of truthness, right? I would predict that we're entering, like there's a convergent divergent cycle of, you know, kind of where things live. You know, right now, the single source of truth for many people is your Outlook calendar in their inbox, right? You know, in engineering land, though, you know, like the single source of truth, like there's no real such thing. Like I can have a single source of truth for the mechanical design. Everything's checked into, you know, Team Center, right? Everything's checked into my SolidWorks PLM. But holy crap, the accounts payable does not use SolidWorks, right? And that stuff matters, right? Like, you know, knowing if you actually bought this widget is as important as the design of the widget. And that is, you know, kind of what this new type of thing that Mark's working on here is sort of helping to solve.
So you know, this sort of idea, you know, now that we've got this GUID, you know, embedded in it, I can go back and find, you know, this piece of back in the database. So we come back and we, you know, this is a database object, you know, now, and we can see it, you know, appear here with all of its attributes. And, you know, I could search, you know, I mean, that's one of the advantages. Now I'm able to actually, you know, choose and search. So I might want to, for the purpose of rendering, you know, click on this and say, let's find, you know, all items created by Parker, or I might want to search and find all, you know, objects that have the same material. So the material definition of this is that, and so let's search and let's find all of the objects in the scene that have that material and apply that material to them. Let's just see, are we still on?
Yes.
Oh, okay. So we actually have database enabled our USD models and connected them, you know, with ontology. Now I might want to find out, you know, do a global search, like, well, where else, you know, how many other aircraft, you know, where is this part across multiple projects, across multiple systems. So part of this, you know, ability to understand things deeply at a relational database level means that we can actually start optimizing not just individual models, but entire supply chains, or collections of models, or, you know, our fleet of aircraft, our complete asset database of you know, plants across the world. I've just received a service bulletin for this pump. Where are these pumps, you know, within all of our plant assets globally? And you know, like specifically in that plant, where is that thing? So I have this ability to change. You know, if I come in here, we can assign a material, you know, we can add the stage, you know, we could add a new material. If I, you know, add this, let's add a nice gold red aluminium, we'll apply to the stage. And so we've got control here. And if I want that same wing, you know, to see that represented in, you know, Epic Unreal, we can simply go here and start that export. We've created an export. We'll now run the Epic Unreal viewer. So it's just on my other screen. Let me bring that across. Lots going on the computer. But there we are. So we're now in Epic Unreal with the same data that we can, you know, see here that we just brought in today's NVIDIA demo. We can go in here and, you know, change the opacity and see into the wing. So we've got you know, examples of you know, many different. Let's go open recent. We'll go. Let's bring in a library. You know, a library model. So while that's loading, so how much time do we have now, Edmar?
Well, it's kind of up to us. We started late, so we can finish late, of course, depending your availability. I know you're busy too, so we can definitely
Sure.
keep going on for a bit.
Okay. So what I'm doing here is just loading a larger model, and this is one of the challenges of visualization is dealing with it. But we will show a model which is a full library and all the HOC. So this is a complete bin model. Yeah, and so we have tools that'll bring in data through ISO 15926, Revit, Navisworks, IFC, GeoJSON, create terrains from GeoTIFFs. So there's quite a lot of different options of how you bring spatial data together, and there's a whole set of tools. If we look here, just while that one's loading, to load all these different sort of formats and point clouds and so forth.
Mm-hmm.
Perhaps one of the things I might do actually, just while that larger model's loading.
We do have a question though, if you want to.
Yeah, sure. I'd love questions.
We have somebody asking how involved the initial setup is. Does Nextspace accelerate dev of Omniverse applications?
Yes. In terms of setting it up, the data that comes into this, immediately that we have this account here, I can literally just go here and go Omniverse, and that's it. That's all I do. I just go. It's what I'm now. When I do that, in fact, we'll do it, and we can upload to your Nucleus server at the same time, and it will create a render. In fact, let's make a new. So we'll run some things at the time. So we'll create a new view of this, for example, and we'll make a bookmark of that. So we can identify it. We'll just call that wingtip. And so we'll export that out, and we'll let that run in the background. So that's going to start an export. Oh, sorry, back to settings. I'll do that again. I forgot to say export to try to do too many things at once. Omniverse, and we'll update to the Nucleus. So that's going to start, and you'll see that it's wingtip. So we've got a few things going on in the background, loading. I'll try to remember what they're all doing. So in here, I just wanted to talk about one of the challenges of bringing data together. So when you talk about setting up Omniverse, we should take a step back and say, okay, we need to bring data together. And I'll sort of highlight it with this demo, which is really in some respects at the heart of what we're doing. So here's a challenge. We've got locally, we've got a whole lot of different local councils, in a very small country, and we've got to manage what's called our three waters, and this is about the pipes, that are for stormwater, wastewater, and supply water or potable water in New Zealand. And so if this data is actually captured by 60 different councils, all develop the perfect representation of a pipe, but unfortunately they're all different. So the moment that you want to bring all this data together from different data sources about what are fundamentally the same things, we have a challenge. So if we have a look, for example, here, people with great wisdom about piping have sat down and decided this is the perfect attribute, a schema for stormwater pipes. And say in a perfect world, all of our pipes would have this data schema associated with them. Mm-hmm. And the problem is that the sources of data come from all these different councils. So if I go to, go for Waipa District Council, we have a look. And on one side, we have the data structure for a pipe that comes in from IPAR. On the right hand side, we have the perfect schema. And so we have all these tools where we can map the data schemas from one to the other. We can put in functions that will concatenate, change coordinate systems, look up dictionary, check spelling, and there's a whole opportunity to put AI in the middle of this as well to find these mappings and do things. So but it's not just one source. So I've got that, and we can go, well, let's look at another account. So they've still got to map to the same target data schema, but with an entirely different input. And what we do is we actually allow the building of this mapping from one to the other, and then we store this mapping. And so these data sources can be static or dynamic through microservices, but every time there's an update at source, we dynamically map that to a common understanding of these pipes, or your pump, or your valve, or your in any piece of engineering information. So what that means is that the original authors and editors and systems, that talk, that have data about the things that you care about, they don't have to change the way things have been done at all. We simply provide a map and a remapping of that data to a single access point of truth that can be now accessed by simulation, visualization in a commonly agreed structure.
Yeah. This is so cool, because then if you took this to another level and say another org wants to then consume all this data from all these separate ones, well, now you only have to map to this unified schema that you've created, and you've got this transitive property going on there.
That's exactly right, and that's one of the biggest challenges with simulation, analytics, and optimization. It's not that we don't have great technology; it's that the task of data wrangling, of organizing the data and data lakes into a single agreed structure that simulation knows what to do with, and then more is just as importantly, how you write the results of AI and simulation back into a commonly agreed data model. Do you update the attributes of these things? Do you change the geometry? And then how do you visualize the results of simulation? Because people need to see this and make better decisions about our world based on the results of those simulations. But until you actually get a framework for communication from this raw data, and back again, it's a tough ask to make the best use of these new technologies, I think. So in here, and if we go to the project views, we can actually look at what that data looks like. We construct a view of that. So it's so much going on in my background. My poor internet's that's still exporting that. And let's see if we've got our here we've got the library loaded up. So one of the challenges here, I need to select, find all of the parts of glass. So I come down, let's just search all the glass material in the system, and so we're running a database search in the background against glass. Right. And see if I did that properly. See the information, Nextspace info view. Oh, I've got a glitch. I'm not seeing my info. I've lost the. Let's just see if I've got. I might be having the demo glitches. We'll let that one. Might be just running slow with everything I've asked it to do in the background. But if I open this project view on this, we've organized, this is how we'd like to organize our data and scene and all that sort of stuff. We'll open the project view. We can actually go and sign in, because you've got to protect, so we need to have access. So let's open the same portal, and we go into a particular, well, let's go into a city. Let's turn on the imagery. Oh, looks like we've got a demo glitch with the background. Not sure what's happening there. I apologize for that one.
It happens to the best of us.
Yeah, that's true. But anyway, that's that sort of overview. We can see, you know, the same sort of concept here. It looks like there's been some disconnects, but this is, you know, just gives you know spatial view of everything.
Yeah.
There you go. So see that, you know, you've got lots of different ways of looking at data, terrain, you know, a beach house. These are all, you know, it's all just different types of data that we can bring together. This is the Barcelona Pavilion. But, you know, it's all about the data behind it. So do we have any other questions as well?
No questions. I think, I think people are just very impressed by the level of detail that you can capture and share. Eric Bowman on our team posted a little while ago that GUIDs are a must-have. He comes from the engineering and CAD background. And he also has a live stream also for anyone watching on focusing on engineering and CAD. You can check it out in the calendar I posted in the chat. Mm-hmm. No, but very cool. I mean, Mark, so what's next for your team? You said you have about 25 engineers on your team about?
Yeah. And we're working through, we have a roadmap. I mean, there's a lot of work going on. One in, you know, the bidirectional interface with the Omniverse. So at the moment we go through and we have a bidirectional data, but we'll be doing more with the seamless integration, material definitions and so forth between USD and the database. We're spending a lot more time on the temporal aspect of data and user interfaces for that, which means that we have more control over, you know, linking with, you know, things like project management, or being able to roll back and forward in time and see, you know, both attribution change and geometry change in smoother ways. There's quite a bit of work going on in the area of database search and the ability to integrate these views, you know, back into traditional asset management systems and you know, consumer environments. So, you know, this framework that we have all sits on, you know, an API. Is perhaps one of the things I haven't highlighted, is that the everything that we've shown actually sits on an API that we publish and links back and forth. So you can, you know, any consultant user can build their own user interfaces around this using and accessing, you know, the data within the digital twin environment through this API structure. So that's one of the important things. So, you know, making those tools ever more easy to use is one of the critical things we're doing. There's the import of the wing. Manually, we're replacing that wing that came in.
And then I posted your website a little earlier. Very easy to remember. It's just nextspace.com. And that's probably the best place for people to go to check out your latest, right?
Yes. Yeah, please go to, you know, www.nextspace.com, and you can see, you know, examples of all of these. Let's see the DPS. Here we are. So we can go down to you know, plant and process demos, and you'll see all this in action and all of the cross. We have tools that automatically cross-reference, you know, hot-spotted, data. You know, we're seeing, you know, a plant. We can click on something like this, and here we are. Documents all associated with it. The valve assemblies. We can see the parts lists and, you know, all that, plus your annotated documents. That
wow.
This is, you know, the hotspots. You know, so that tag number, you know, is linked back with, you know, that that tag number, and so these associations are made automatically, not just at a document level, but to a hotspot level. So there's a lot of tools that we don't have time to go into today, but certainly would encourage people to get in contact with us, and we can go into any details that people are interested in.
Really amazing.
I like this so much. It's such a pragmatic approach. Instead of waiting for everybody to sign on a standard or accepting that standards are going to change, just you're providing the tools so that to make it easier to be able to adapt and grow.
Yes, we certainly, thank you for asking. I mean, we certainly, standards are important, but, ultimately there's going to be, hundreds of them that you have had that you've got to integrate, and they'll change next Tuesday. And our view is that, people often ask us, what standards do you use? Well, we don't, we provide a tool to embody standards that are dynamic and changing. So you take your Omni class, you take your OC, you take whatever standard you have, and we have a whole bunch of tools to join standards and manage the standards problem, rather than saying we support that standard or this. We support all of them, because standards ultimately are around building data schemas and deciding the things that are important, the attributes that are important, the visual proxy processes involved, and so forth. And the problem has not been standards themselves, and so many digital twin and data problems end up getting mired in standards discussions, which can go on for years. And in fact, are no longer really that necessary, to be blunt.
Yeah, I love that quote about that you had earlier, and with the you have the solution today. You don't need to wait for everybody to finally agree on what was the way forward. Just you'll have a solution for them today, because you can adapt for whatever comes in the future.
Yes, exactly.
That's awesome. Mark, I can't thank you enough for spending this time to go with us. I think this is super enlightening for a lot of people, including myself. Just seeing the breadth and depth of the data, and how to leverage all these different data sources and tie it all together so that you're not missing anything in the process. But being able to see how it connects to all these different formats that you wouldn't think are related to each other at all, but being able to see them all connected like that, I think it sounds like it's a real lifesaver for companies. I could see why you have such a great list of companies you worked with. So really excited that you're leveraging the Omniverse also to do this work. So thank you for sharing this with our community.
A pleasure.
And thank you very much to Maddie for switch hitting on for the queen of the stream. So hopefully Wendy's computer's not up in smoke right now, but we'll be back for our live stream next week. I think we're going to be covering Blender and audio to face. Some super exciting stuff happening in that area for people who are working on avatars. We're going to be showing some really cool workflow that is just hot off the press. So join us then. You can catch all of our streams on our calendar. I posted that in the chat. And of course, don't forget to register for GTC. Register early so that you can get updates on the content you're most interested in. So we kind of know what you're looking for, and we'll give you updates accordingly. NVIDIA.com/GTC. Again, Mark's website is Nextspace.com. His team is based in New Zealand. We want to give all of them big thank you for all the great work they're doing. And thank you, Mark, for telling their story. Really exciting to share this with everybody. So thanks, everybody.
Thank you.
Thanks, Edmund. Thanks, Maddie.
Until next time.